Hello, I welcome you all to EDUKEM channel. In this video lecture, we are going to discuss about the next part of chemical bonding. Those are polarization and dipole moment. So you might have seen this kind of picture. This is called polarization. In the further slide, we are going to discuss about the detail of this polarization, how the shifting of electron has occurred in the anion. We will discuss about the dipole moment. Okay. So without a doubt, let's start. Now, polarization. First, we will understand the statement of polarization. When a cation approaches an anion, the positive charge of cation attracts the electron cloud of the anion towards itself due to the electrostatic force of attraction between them. The cloud of anion is elongated towards the cation. This distortion or deformation is called the polarization. So what is the meaning? You see, when a cation is approaching the anion, okay, so what will happen? The size of cation is small, the size of anion is big. So when the cation approaches the anion, what it will do? This cation is going to attract the electron cloud of the anion, right? So what will happen? As it is attracted by a cation, the electron cloud of the anion is elongated towards the cation. You see, the cloud of anion is elongated towards the cation. So this distortion or deformation of anion by a cation is known as polarization. I think this point is clear to you, right? So next, polarization is directly proportional to the covalent character. That means if a compound has more polarization, that compound is more covalent. Okay, covalent. Okay. Next one is, you have to remember this point, charge on anion. If more charge on anion is present, that is directly proportional to the polarization. And more is the polarization, more is the covalent nature. And more covalent nature, that is inversely proportional to the melting point. Generally, the covalent compounds has low melting point, right? So next, note that magnitude of polarization depends upon the number of facts suggested by Fajans rule. So you have to remember, according to the exam, when the exam asks about what are Fajans rules, so you have to answer according to the different points. Okay. So if Fajans rule is clear, that means that you can easily solve more and more type of questions. So let us just first understand what are these Fajans rule. Okay. Now let us discuss about this Fajans rule. Okay. Factor affecting the polarization. So all the factors which affect the polarization is known as Fajans rule. All the factors will affect the polarization we are going to discuss through the Fajans rule. So first point, size of cation. Polarization increases as the size of cation decreases. That means the polarization is inversely proportional to the size of cation. Remember, this is size of cation. We'll go to the example. BeCl2, MgCl2, CaCl2, SrCl2, BaCl2. So what is the difference in this compound? The difference is size of cation. So size of cation down the group, it is increasing, right? So if size of cation increases, that means polarization is decreased. So covalent character is decreasing. Or you can also say that as the size increases, polarization is going to decrease. So polarization decreases, that means covalent character decreases, right? As we have mentioned in the earlier lecture, that as we discussed, polarization is directly proportional to the covalent character. Okay. So down the group, our covalent character decreases, and covalent and ionic character both are inversely proportional to the compound. So covalent character is decreasing, whereas ionic character is increasing. Okay. So we can say that BeCl2 has more polarization, right? If more polarization, that means we can say that BeCl2 is more covalent. Next, coming to the a note, greater polarization power of Be2 plus shows the maximum covalent character in BeCl2. Why? Because BeCl2, the size of cation is small. Size of cation is small means polarization is more. Polarization is more means covalent character is more. So the next part of Fajans rule. Second point, point number 2, size of anion. size of anion increases for a given cation, the covalent character increases. That means polarization is directly proportional to the size of anion. More is the size of anion, more is the polarization. More is the polarization, more is the covalent character. Let us see the example: CaF2, CaCl2, CaBr2, and CaI2. Now tell me. So size of anion down the group increases. So if the size of anion increases, that means the covalent character increases. Or you can also say that size of anion increases, the polarization increases, right? If the polarization increases, covalent character increases. And covalent character and ionic character, they are inversely proportional to each other. So what happens here? CaI2 is more covalent. More covalent. Okay. Next, try to solve these questions. The most covalent compound halide is, I think you have already solved the question. First option is AlF3, AlCl3, AlBr3, AlI3. Now tell me what is the answer. The answer is D. AlI3 means iodine is bigger in size compared to all these compounds. So more polarization will happen in AlI3. If more polarization, that means more covalent character. Next, we are going to discuss about dipole moment. So before going to the statement, let us just briefly understand what is the meaning of dipole moment. See, dipole, what is the meaning of dipole? Two pole has created, okay? So the concept says about the movement of the charge. What is this charge? This charge can be a positive or a negative or a same type of atom, okay? If it is same type of atom, there won't be any movement. Or if different type of atom is there or electronegativity difference is there, that means the electron will shift towards the more electronegative atom. So there is a movement of shifting of electrons, remember, okay? So now coming to that statement definition, the product of magnitude of charge and the distance between the center of positive and negative charges. What is the meaning? You see, let's suppose two charges created here. One is positive, another is negative. So what happens? The product of magnitude of charge and the distance between the center of positive and negative charge. So this is the distance between center of positive and negative charge. Okay, D. So dipole moment mu is equal to Q is the charge. And what is D? D is the distance. Okay, so you can also see a statement magnitude of charge into distance. So charge into distance is known as dipole moment. Okay, I think this is clear to you. Or a simple word, you can say that the movement of the shared pair of electron towards a more electronegative. Now try to understand what are the important points. Point number one, dipole moment is a vector quantity. So what is a vector quantity? The quantity which has both magnitude as well as direction. So now understand what is the meaning. Let's suppose two atom is there, atom A and atom B, okay? And B is more electronegative atom. So if B is more electronegative atom, that means the pair of electron will shift towards B. So the movement of pair of electron towards B is known as dipole moment, and that movement is represented with a vector quantity. Okay, so as we already know, a vector quantity represent both magnitude as well as direction. You can also say there is a tail. Okay, this is much more clear picture. The direction of dipole moment is represented by the arrow mark pointing from the positive to electronegative atom. See, this is a positive and this is a negative. So direction is always from positive to negative. Why negative? Because B is more electronegative. So it is going to pull the electron pair from A. So that's why the direction is always from positive to negative. So this is a picture of, this one is the center atom, this is the lone pair. So direction is from center atom to lone pair. If lone pair is present and if more electronegative atom is there, that will also follow the same rule from positive to negative. Next, third point, unit is debye. So you remember the unit of dipole moment is debye, and 1 debye is 3.33 into 10 to the power minus 30 coulomb meter. So what is the unit? You can also write debye is the unit or coulomb meter is the unit. Next point, in diatomic molecule, dipole moment depends upon the difference of electronegativity. So dipole moment is directly proportional to the electronegativity difference. So what is the meaning? Meaning is, see, here is the example, dipole moment. HF is more dipole moment than HCl, than HBr, than HI. Why? Because fluorine is more electronegative. If fluorine is more electronegative, that means it is going to pull the shared pair of electron towards the fluorine, and that compound will have higher dipole moment. So dipole moment of HF is more than HCl because dipole moment is directly proportional to the electronegativity difference. So hydrogen is constant, so the only difference is the fluorine. Now for the diatomic molecule, you remember, for diatomic molecule, dipole moment is 0. So diatomic molecule examples are H2, F2, Cl2, Br2 and O2. So for all diatomic molecule, dipole moment is 0, you remember, okay? So now I'm going to tell you about polar and non-polar. If dipole moment is 0, then we will say this is a non-polar. If dipole moment is non-zero, that is polar molecule, okay? So you remember, so HF is polar and H2, F2, Cl2, Br2 and O2 is non-polar. So this one is non-polar. Okay, you just remember. For the polyatomic molecule, dipole moment depends on the vector sum of dipole moment of the covalent compound. So what is the meaning? More atom is there, that means more than 2 atom is there, that will depends upon the vector sum of the dipole moment. Just like the physics says about, if 2 vector is there, the resultant vector will be summation of A and B. Okay, so here is also same concept is happening for polyatomic molecule. Let's suppose we'll take the polyatomic molecule as BF3. So boron 1, 2 and 3. Okay, so here what will happen, we have to decide the dipole moment of this compound by drawing the resulting vectors. Okay, so as we know that boron and fluorine is more electronegative, so the direction will be towards the fluorine. Here is also towards the fluorine, here is also towards the fluorine. Now the catch is, as you see that all BF3, there is no lone pair. So if no lone pair, and it is going to follow the regular geometry. So no lone pair is equal to 0 and regular geometry. So which are those regular geometry? One is linear, trigonal planar, tetrahedral, trigonal bipyramidal and octahedral. Remember, these are the regular geometry. So regular geometry, 0 lone pair, they will have 0 dipole moment. Okay, so like PCl5, there is no lone pair, and PCl5, the geometry is trigonal bipyramidal, hence the dipole moment is 0. CH4, no lone pair, follows the regular geometry, dipole moment is 0. Okay, now what if the molecule has a lone pair? So in that case, again we have to see the sum. So let us talk about the few examples. This one is NH3. So as we already know that nitrogen has one lone pair, so the direction here will be from nitrogen to lone pair. Okay, again nitrogen and hydrogen, which is more electronegative atom, that is nitrogen, so direction will be towards the nitrogen. So this is the direction of the vector, and above is the direction of the vector, but here it is going up. So 4 vectors going up. So what will be the net direction? Direction in the net direction will be up. So now tell me, it's a polar or non-polar? Mu is equal to 1.47 dBi. So that means mu is not equal to 0. So if mu not equal to 0, what will say that it's a polar molecule. Okay, lone pair is there, it's a polar molecule. Now coming to the next example, NF3. Now the situation is, see here, one vector is going up, another three vector is going down. So three vector is going down means the resultant vector is going down. Okay, so now see, there will be dipole moment, but the dipole moment of NF3 is less than the dipole moment of NH3. This has asked many times in the exam. So what is the reason? Reason is, you see, fluorine is more electronegative, hence the direction is downward, whereas hydrogen is less electronegative than the nitrogen, hence the resulting vector is going up. You can take the example of water. As you already know that oxygen, it also two lone pair. So the direction is from oxygen to lone pair, from here hydrogen to oxygen. So net dipole moment is going up. So the dipole moment is 1.85 dBi. Okay, I think this concept is clear to you. So now it's question time. Question number 1, 2, and 3. I want you to solve these questions and let me know in the comment section. Okay. So what is the answer for question number 1? The molecule possesses dipole moment. What is the answer? This has no lone pair. This is no lone pair. This is also no lone pair. Center atom. Okay. So what is the answer? Answer is B. The compound which contain both ionic and covalent bond. Answer is C. The type of bond present in NH4Cl. I think we have already discussed the structure of NH4Cl. Okay. So NH4, H4, and there is Cl. So Cl. Okay. So if you separate the cation and anion part, you will get ammonium ion and Cl minus. So it has both covalent, ionic, and coordinate bond. Electrovalent bond, covalent bond, and coordinate bond. So answer is A. Thank you for watching this video. Like and subscribe EDUKEM channel. If you want to connect with me, my social media account, my Instagram is this, and my Twitter handle is this. Thank you all.